So I have my calculator out. Hopefully you've managed to get a calculator, hopefully specifically the calculator that I use. I'm going to use it a lot in this section, so you should have a calculator handy. It's going to make your life easier to do some of what we need to do. Um, this section is called linear equations. And what we're going to do in this section is we're going to be given an equation that has a variable or has one variable in it. And we're going to try to find a number that we can plug in for the variable so that when I substitute it in and simplify, both sides of the equation come out to be the same number. This is called solving a linear equation. We're going to learn algebraic steps to figure out how to get the answer, and then we're going to check all of our answers, and it's the checking that I'm going to use my calculator for. I get, I think, a little bit overzealous here, and I wrote steps to solve a generic problem that comes up in this section, but these steps don't apply to every problem. So I'm going to make up little short snippets from this to solve the problems rather than using this whole list. So my goal in problem 2, which would be the first problem I do, is to find a number I can change the y to so that both sides come out to be 14, because the right side is only 14. And so my goal now is to get the number on the opposite side of the equation. Because the number is added, I need to subtract it to get it to the opposite side of the equation. So always my goal is to get the variable by itself with a coefficient of 1 on one side of the equation and the number, that's my answer, on the other side. For this first problem, I'm just going to collect all of the constant terms, the terms without the letters, on one side of the equation, and I do this by doing the opposite. If a number is added to the variable, I subtract it. So this is a simple one-step problem number 2. I'm going to subtract 6 from each side. On the left-hand side, that's the 6's are going to cancel. I'm going to bring down the y because I didn't subtract it. And on the right-hand side, I can do 14 minus 6 in my head. But if you can't, pull out a calculator. I claim this is the answer because anytime I get the equation set up so that there's a variable on one side with a coefficient of 1 and a constant, a number without a variable, on the other side, that should be the solution. And any time I solve an equation, I'm allowed to check. I'm going to take the answer that I think is correct, which is y equal to 8, and change the y to 8. If the y doesn't have an exponent or a coefficient, when I do the checking, I'm just going to plug the number in place of it without a parentheses. So to check, I'm going to change the y to 8, and I'm going to simplify. If both sides come out to the same number, I put a check mark. I have a correct solution. All the problems in this section will only have one solution. It turns out that you need exponents like 2 or 3 to get more than one solution. If I thought for some reason, if I made a math mistake, let's say my algebra, instead of subtracting 6, and let's say I made a mistake, and I said, oh, I need to add 6 to both sides, which isn't right. And if I thought y equal to 20 was the solution, and I went and checked, I'd go 6 in for y. I'd go 20 in for y. 20 is the answer that this algebra gave me. Plus 6, going back to the original problem, equals 14. And it will always be the case that if you have a wrong answer, you'll get a false statement. It won't be the same false statement, but you'll get the left side of the equation doesn't equal the right side of the equation, so you know you've made a mistake. So for the first few problems, they're just a variable with a number added or subtracted from it, and I can solve those with one step. If a number is added to an equation, to a variable, I subtract it. If a number is subtracted, I add it. So 3 and 4 are one-step problems. I'm going to do my algebra for 4. My goal is to get the variable preferably on the left side, but it could be on the right side, and the constant, the number 1 constant by itself on the right-hand side. This is kind of similar but the opposite of number 2, because the number that's combined with the y is being subtracted from it. So I need to isolate the y. I'm isolating the y by, what I'm doing is I'm collecting the constants on one side of the equation. I'm collecting the constants on the right-hand side. Constants are numbers without letters. And on the left-hand side, the 15s will cancel. I'll bring down the y. On the right-hand side, 23 plus 15 is 38. I claim that's my answer. The nice thing about this section is I can check every problem so I don't ever have to write down a wrong answer. I'm just going to change the y in the original problem to 38. Simplify to make sure both sides equal the same number. Doesn't matter what number is on each side is the equal sign as long as they're the same. Those are baby problems. Now this is kicking up the difficulty a little bit, but I'm using my calculator. My calculator rocks on fractions if I don't. So 6 is very much so like number 2. And again, I'm just going to collect the constants, the numbers without the variable on one side of the equation by adding or subtracting as needed. That's the only step that the first 10 problems, the first 8 problems need. So I'm going to do minus 3/4 from both sides. On the left-hand side, I'm making the 3/4 cancel. I still have the y. And on the right-hand side, what I'm doing is 11/4 minus 3/4. And if you don't want to do fractions by hand, this is one that's pretty easy to do by hand. For this test, you can use your calculator to work on the fractions. My calculator tells me it's 2. This is because 11 minus 3 is 8. When you're subtracting fractions with the same denominator, only the numerators change, the denominator doesn't. You get 8/4, which is 2. So I claim this is my answer. Checking is often the hard part. To check by hand would be kind of not pleasant. I'll show you it by hand. It's good to be able to do it by hand. If I wanted to check by hand, I need to take this 2 that I changed the y to, make it a fraction that can be compatible with the 3/4. So I wrote 2 as 2/1, which is the fraction form of 2. I'm going to multiply it by 4/4. This is going to make the left side 8/4 plus 3/4. The right side is fixed at 11/4. And now these two fractions have the same denominator. So I'm going to combine the fractions by adding the numerators. And I get a true statement. If I was checking, I would just do this. Go 2 plus fraction key, 3, move down to the denominator with this kind of mouse thing over 4. And you get 11/4 for the left side. That equals 11/4 for the right side, so I know my answer is correct. I'll do the fraction work by hand just because I think it's good to see. And if you can do the fraction work by hand, the higher you go in math, the more you need to be comfortable with fractions. Since we've already tested on doing fractions by hand, I'm assuming you can do it if you had to. Problem 8, I need to isolate the z this time, and I'm going to write my z with a line through them because otherwise my z's look like 2's. So I'm going to get z on the left-hand side. I'm canceling out the 5's. And on the right-hand side, I have 2/3 plus 5. I would add that on my calculator if I, wasn't trying to just recall some fraction work. If I want to, do by hand, I'm going to make the 5 into a fraction so I can get it to have a denominator that's compatible with the 2/3. And so this is going to give me z equals 2/3 plus 5/3. And I claim that my answer is z is 7/3. If I check every fraction by hand, I'll never get through this video in a time that is, acceptable. So I'm going to take this z, I'm going to change it to 7/3, and I'm going to make sure that when I simplify the left-hand side, that it matches up with the right-hand side. So when I plug in 7/3 for z by hitting my fraction key, then 7, move down to the denominator 3, arrow out of the denominator minus 5. If when I hit equals right now, if I see 2/3, then the answer is correct. If I see any number other than 2/3, my answer is wrong. So when I hit equals, I see -8/3. That's not good. So this means I made a mistake that I didn't realize that I made. And that's not the worst thing in the world. Oh, and I see my mistake. So this is really good. This is the reason we check, because we can go through and think we're not making an algebra error, but maybe you saw my algebra error. When I went right here, when I multiplied the 5/1 by 3/3, I should have written 15/3 here. The fact that I made that insignificant mistake, it made my answer not check. It wasn't an on-purpose mistake, but it was a mistake nevertheless. So my answer should be 2/3 plus 15/3. My answer should be 17/3. And now let me check 17/3. So let me recheck, put in to see if 17/3 minus 5 equals 2/3. It's actually good when I make a mistake like that, if I catch it. If I don't catch it, it's just horrendous. But if I make a mistake and I catch it, boy, that's what I want you to be able to do too. Making mistakes, we're all going to do them. But in this section, there's no reason to write a wrong answer down, because you can check every single answer, and you can check by pressing buttons, and that's not so hard to do. So 7/3 that I wrote down as the answer, well, in fact, it wasn't the answer, and 17/3 is actually the answer. So that's the first 8 problems are one-step problems. What they all have in common is they have a variable that has a number added or subtracted to it. And to get rid of a number that's added or subtracted to a variable, you add or subtract, you do the opposite. The next few problems have a single number multiplied by a variable. And in these problems, if there's an integer multiplied by a variable, these are one-step problems. And to solve these problems, I'm going to divide both sides of the equation by the coefficient, the number to the left of the variable, if the number to the left of the variable is an integer. And in problem 10, that's the case. In problem 10, I'm going to solve, because the number is multiplied in kind of the opposite operation of multiplication is division. I'm going to divide both sides by 4. And on the right-hand side, I don't need my calculator. Apparently I do, because I almost just wrote a mistake. I think 28/4 is 7. This is my answer. I should always check. Anytime I think I have a correct answer to a problem that has an equal sign, I can check. And in this case, I'm going to start using a parentheses for my checking. In the first few problems, there wasn't a coefficient for the variable, so I didn't really need to use a parentheses when I'm checking. But here, usually when I'm checking if the variable has a coefficient, I use a parentheses. So I'm going to go 4 times 7, and I'll get 28 equals to 28. So my answer is perfectly checked. it doesn't matter if the coefficient is negative or positive. If the coefficient is